So before you get started on the review for this chapter, I want to just make a quick cheat sheet that will help you try to organize your thoughts. This is definitely one of the hardest things that we do here in, I would say, the whole year, including geometry. And so this will hopefully help you kind of organize your thoughts a little bit. So we went over a lot of different ways to count the number of uh, we went over a lot of different methods to count the number of ways that something can happen. Um, and so here's kind of a thought process to use when you're trying to pick the method that you're going to use. So the first question that you want to ask yourself is, are you choosing one item from a group, some items from a group, or are you choosing the entire group? Are you choosing all of the items? Okay, that's going to be the first thing when you read a problem. That's going to be the first thing you want to ask yourself is, am I choosing one, am I choosing some, or am I choosing all? So if you're choosing one item, that was from Learning Target 2.1. Um, and we learned about the fundamental counting principle, where you're choosing one item from multiple groups. So I'll just kind of say a couple examples. There is another video that will go through examples as well. Um, but something like you're going to an ice cream store and you're going to choose one flavor and one topping. How many different ways can you choose those based on how many different options they have? Or you're taking a test that's true and false, and there's 6 true and false questions. Well, that's still choosing one item from multiple groups. In this case, the groups, quote unquote, is each question, and for each question you have an option of true or false. So there's 2 options, and you're doing that 6 times. Answering a multiple choice question, kind of the same thing. If there's 3 multiple choice questions and there's 4 options, you can use the counting principle, fundamental counting principle for that. I did in the notes, I did point out how we can use exponents. Honestly, for some of you, I know that really confuses you on when to use exponents. So one thing to just understand is that the exponent method is really just a shortcut to the fundamental counting principle. Okay. And so if that doesn't make sense to you, then just forget about the exponent method, because you don't necessarily need it, but it is meant to just be a shortcut to save you some time. But if it's something that just throws you for more of a loop, then it's probably not an effective shortcut for you to use because it's no longer a shortcut. Okay. So again, in the notes on 2.1, I did go over and use some exponent examples, but that's really just a shortcut to the fundamental counting principle. Okay. If you read the question and determine that you are choosing some from a group, okay. So there are 10 people in a race. How many can the top 3 finish? So you're only choosing 3 of the 10. Or 15 people try out for a team, and you're only choosing 8 to make the team. So again, you're choosing 8 of 15. So if you are choosing some items from a group, then you have kind of another level that you need to ask, or another step to ask yourself is, does the order matter? Okay. So in your notes, this is where, if I just use the racing example, this is where there's a slight difference. If I said there are 10 horses racing, how can the top 3 finish? That would indicate that order does not matter, because it doesn't matter if you finish first, second, or third. You are being labeled as top 3. Okay, now, similar question. 10 horses in a race, how many different ways can first, second, and third finish? Now the order matters. Okay, now we have identified unique positions. There's a difference between finishing first, second, and then finishing third. Okay, so if order matters, then that's when you use a permutation. Again, we're just using decimals for that. If order does not matter, then that's where we're using combinations. Okay. And then if you're choosing all from a group, whenever you're choosing every item, so a common question is, there are 9 people and they're trying to stand in a line. How many different ways can that happen? That's where you use your factorial symbol. So just 9 factorial. Okay. So just a quick review there, and something that should help. I would make sure I get these down as notes, because it's something that should help you kind of organize your thoughts as you're trying to figure out which method is going to you're going to use to determine the number of ways something can happen.